All right, here we're going with a question on the central limit theorem and specifically looking at proportions. Um, so what the central limit theorem is, it looks at the sampling distribution, which is what a statistic would be. If you take a sample, get the statistic, take another sample, get the statistic, get another sample, get the statistic, and then you plot all those statistics. So that plot, that distribution of statistics, we know three things about it. Let me write those real quickly. So we know that the mean of this distribution, so the mean of the distribution is actually the same as the mean of the original distribution. So in a proportion, it'd be whatever the proportion of the overall population is. The standard deviation here, standard deviation of this proportion would just be the population proportion times 1 minus that value divided by the sample size. And the other, let's see, I think you have all these formulas down here also. Yeah. Okay. The third thing is that the shape of the distribution is a normal distribution. So the shape of that sampling distribution of all these sample statistics is always going to follow a normal distribution, which means we can use our z-score conversion. So that's what we're going to do on this problem. So the first thing they do, we'll maybe take a minute to read the problem. We're looking at a case of potential discrimination or bias. We know that 10% of applications were from minority candidates, and exactly 9% of the positions were filled by minority. Sounds close, but what's the chance that if the true portion is 10%, that we would get 9% actually filling them? Is that evidence of discrimination? That's what we're looking at here. So the mean of our proportions here is just going to be the proportion of the population itself, which they tell us exactly 10% of all applications were from minority candidates. So we can, it's not letting me put that in since I looked down there, but that would be 0.10. So this over here, the mean would be 0.10. In fact, I can put that in here, 0.10. What about standard deviation? Standard deviation is going to take a little bit of work here, but not too bad. So we take that mean, that 0.10, 0.1 would work fine. Multiply it by 1 minus that, which is 0.9, over the sample size. And here it looks like our sample was 900 applicants. And this is going to give us approximately, do this calculation here quickly. So this would be square root of 0.1 times 0.9 divided by 900. You should get 0.01 there, and that's not rounded, so that does continue out by a couple places if we would want as many as we want, actually. All right, so here we have mean and standard deviation. What's the approximation for the portion of these samples that would be less than 0.09? Well, we've got all the information we need about the distribution here. So now it just boils down to being a z-score calculation problem. So remember, the formula for z-score is right here, x minus the mean over standard deviation. And what do we have for our x? Well, our x is this cutoff right here, this 0.09. The mean we already found was 0.10. And our standard deviation we also found right here, 0.01. So when we calculate this, we find negative 0.01 over 0.01. So this would be -1. Just reiterate that if we carry it out a few places. A z-score of -1. So what does that tell us? Well, that tells us we're over here on the distribution. Negative z-scores are always below the mean. But we want the portion, let's see what it's asking us. We want the portion that our probability would be less than that value, less than that z-score of -1 or that p of 0.09. So in other words, we want this right here. Luckily, Alex has a nice button on the calculator that'll do precisely that for us. The portion that z is less than or equal to negative, make sure you get that in there. And that would be 0.1587. So 0.1587. So 15.87% of the distribution, or of samples of size 900 that we would pool, would have a portion that were 9% or less. So is that evidence of discrimination? Probably not. I think the courts like to see 0.05 or a little bit less, so 0.1587 would not be as convincing. But at the same time, it is leaning in that direction enough to maybe keep an eye on things. Of course, that's going a little more in depth than we really need to at this point.